Welcome. Let's take a look at the case of trying to find the area to the right of a z-score, and we'll use our normal CDF function. So let me take a look at this example. So it says find the area right of z equals negative 1.25. So let me go ahead and shade the picture here. So we'll be working with the standard normal distribution, and our z-scores then, the mean is 0. So a z-score of negative 1.25 would be to the left of 0 on that number line. So we'll label that. And we're interested in finding the area to the right of that value. So as I'm shading here, in theory, we would shade forever to the right. So z, we would say, would increase without bound. So this concept of infinity, z-scores continue indefinitely. But we can't work with that as an upper bound because the calculator needs a lower bound, a numerical value for that. And we have to enter something for an upper bound to calculate an area. So the area under the normal distribution becomes smaller and smaller the further to the right we go. Eventually, it becomes negligible. So in order for us to find probabilities as accurate as we need, we're going to just pick some big number to substitute for infinity to enable us to find these areas. So what we'll be doing if the upper bound, in this case, thinking of infinity, we're going to replace it with just a really big number. And the number that we're going to use to substitute for infinity is 1 times 10 to the 99. So that's a 1 with 99 zeros after it. So I put them all here so you can see we're just picking some really big number, and that will enable us to put in a value for the upper bound and find this area that we're looking for. So 1e99 on our calculator would be equivalent to that 1, moving the decimal right 99 places. So that number, 1 with the 99 zeros, is called a duotrigentillion, and that's going to be our stand-in for infinity. All right, so let me write this question also as a probability. So this would be equivalent to asking, what is the probability that a randomly selected z-score, so to the right would be z-scores larger than that value? Okay, so to find probability or area, we use our normal CDF function. We start with our lower bound, negative 1.25, and our stand-in for infinity. So we're going to do 1e99, and it turns out you don't even have to put that 1 in the front. It's implied there. So we can just enter e99 and then go to our calculator. So I'll show you how to enter that. So normal CDF first, so distributions, so second distributions. Let me make my calculator just a little bit bigger. Okay, so distributions, normal CDF, and then negative, so you're going to use your negation button, negative 1.25, comma. All right, to get the E, above your comma button, you're going to see EE. So if you hit second comma button, that EE will put that individual E on the screen, which is what we want, and then 99. All right, and you don't even have to close parentheses. We'll just hit enter, and we'll round that to 4 decimal places, 0.8944, 8944. So as a percent, I've shaded 89.44% of that normal distribution. Okay, so let's do one more. So find the probability that a z-score is greater than positive 1.25. So positive values are to the right of 0. And we're looking for the probability of a z-score greater than that. So in theory, we're going to shade forever to the right. So for our lower bound, we substitute for our infinity, our duotrigentillion number. So normal CDF, positive 1.25, and then E99. All right, so distribution, so second distributions, normal CDF, 1.25 comma, and then above the comma is the EE. So second comma puts this single E on the screen, 99. And that is 0.1056 or 10.56%. So what I want to point out in these two examples is that in the first one, I've shaded more than half the picture. In the second one, I've shaded less than half the picture. So it's always good to think about percentages. Half of the picture would be 50%. So this percentage is bigger than 50%, more than half, and that one is less than half the picture, so less than 50%. Okay, so let's take a look at our last case. So that's how we find areas to the right of z-scores. And now let's look at finding areas to the left of a z-score. So for this example, we're going to do left of negative 1.50. So negative 1.50. And now we're looking for the area to the left of it. So in theory, these z-scores again will increase or decrease without bound, so they will continue to the left forever. So this concept of negative infinity, but we have to replace that with a number. So the calculator needs a numerical value for its lower boundary. So lower boundary always to the left of the upper boundary when we define a region. So we have to put a number in for this. So we're going to use our negative 1E99 as a stand-in for negative infinity. So a negative 1 with 99 zeros after it. So just this really big negative number. So this would be equivalent to saying, what is the probability a z-score is? So to the left would be z-score smaller, less than negative 1.50. So the most important thing to remember when we're looking for area is lower bound is the left of the upper bound. So for the lower bound now, we're going to start with negative infinity. So we can do negative, and you can leave off the 1 again, it's implied. So you can do negative E99 for negative infinity, and then we would keep shading, ending at an upper bound of negative 1.50. And that answer should be less than half the picture, so less than 50%, and we'll find that out right now. So normal CDF, so negate, and then your E99, comma, negative 1.50. All right, and that is coming out to be 0.0668, which is less than 0.5. So in decimal, 0.5 is half the graph. As a percent, 6.68%, and that's certainly less than 50%. So just always good to think about comparing it to 50% of that picture. All right, one more over here. So the probability z-score is less than 2.25. So we're getting all the way out here on our graph. So the probability z-score is smaller. So now I'm seeing this area is going to be getting pretty close to 100%. This is almost that whole graph. So to the left, shading in theory forever, we'll replace that lower bound with our negative duo trigintillion number, and then our upper bound, 2.25. All right, so normal CDF, negative E99, negative infinity, up to 2.25. And I'm expecting that to be getting close to 100% of that graph. We'll find out. So back to our distributions, normal CDF. So negative E99, 2.25, the upper bound. And that is almost 1. It's 0.9878. So in decimal, the whole graph would have an area of 1. In percents, this is 98.78%. So in percent, the whole graph would be 100%. So we're getting close to the whole graph there. All right, so The most important thing is that you know that the order matters when you input values into the normal CDF function. You have to be really careful to put the order in correctly when you're looking at area to the right of the z-score versus area to the left of the z-score. So if it's area to the right of the z-score, normal CDF, you're going to start with the 1.75. That would be your lower bound. And then you're shading to the right infinitely. So the E99 would be in that second position. So lower bound, upper bound. All right, versus, let me come over here. If you were shading to the left, like this picture, if you're shading to the left, the lower bound is negative infinity. It's our negative E99. And the upper bound is the 2.25. So it's really important that you get the order correct in each of those two cases. So in all cases, the area or the probability needs to be a positive number. So you'll know that you've done something wrong if you end up with a negative value here. So if you put the order in correctly, I'm going to just clear my calculator, you'll be good. So normal CDF. So if I'm shading to the right, you start with your value and then shade to infinity. So that's 0.0401. I'll just leave it in decimal now. If you're shading to the left of a value, so z-scores less than, you're going to start with your negative infinity. So normal distribution, normal CDF. So shading to the left, start at negative infinity as your lower bound, and then your upper bound will be that value, in this case, the 1.75. All right, and that is 0.9. And I'll be careful here getting the rounding right. So 95, actually 99, 0.9599. All right, and those are our two cases to be careful with. Shading to the right, value positive infinity is the order. Shading to the left, negative infinity, and then the value will be the order.